Hi, folks. Welcome back. So, in today's session, let's talk about this Kubernetes Gateway API. So, in the previous, videos, we have already come across with this Istio gateway, how, we can define the gateway, which is tightly integrated with a particular kind of load balancer based on what kind of gateway you define. It could be an external or internal. And then you define the virtual service, which you for a particular Kubernetes service, and how you can, consume. It could be for that virtual service. For example, if you're defining in a particular namespace, in that namespace, what are all the different kind of backend applications, are the microservices which you are defined. Each you can pass through a different uh, layers. Are I mean, it's about, like, you basically consume from virtual service. Basically, it's on top of Kubernetes service, and then virtual service host, whatever you define, that particular host, the definition will be mentioned inside a gateway, and through which, we reference that. That's a typical explanation for Istio gateway and all. So you have already seen the another classic stuff, which is, the ingress, which is Kubernetes ingress. So I hope, anybody who worked on Kubernetes from, last couple of years, or even the beginner also, they must have already, familiarized with the ingress. So when we already have this ingress, the Kubernetes ingress and the STO gateway and all those stuff, then why do we need this gateway API? So what is this, the gateway APIs? It's just, it's just in a short, we can just say that it's an enhanced or an upgraded or, the improved version of an ingress API, you can say. So it comes with its own wonderful features. It's like it's a modern API traffic management system, you can say, where, you can route the traffic based on different kind of, the protocols. It could be a TLS, it could be HTTP, UDP, whatever it is. So if you see the architecture diagram here, you have the gateway class at the top, and then it's basically it's a cluster scoped resource, the gateway class is. So which typically, provides a kind of a, or sort of a template to provision a particular kind of a load balancer. So that definition, basically, what kind of load balancer you have to provision. So that is there with your gateway classes. So each cloud provider that comes with their own controller. For example, GKE has GKE controller, and then that comes with a different kind of, the gateway classes. Similarly, Azure has the Azure controller. No, it's a cloud specific. So, but ultimately the functionality is so generic that it's completely portable and flexible to use it across any of the cloud environments. So below the gateway class, you have the gateway. So as I said, based on the template, whatever it provides, you will be provisioning different kind of a gateway, which actually provisions your load balancer. And here you are defining how your traffic should look like, what kind of protocol. It could be an HTTP or HTTPS. All those stuffs basically you mention here. And then the route, this is the place where actually you define a traffic, where it has to go, how it has to route. It could be an HTTP, or it could be an HTTPS or TLS based on whatever the service, basically the Kubernetes service, the expose port. So you will be leveraging those, and then you will be defining the routes. So don't worry about that. We will see an example how this HTTP route, is defined, how this gateway is defined, how we can leverage the different sort of in gateway classes and all. So that's about, at the high level, what exactly this Kubernetes API is. So some of the key features of this gateway API is, as I was mentioning, so it's just, it's like separates whatever the stuffs which you used to do. For example, like, the infrastructure administrator, basically he can provision the gateway classes in advance, so that a individual, or I mean, he can, basically provide what are all the different kind of the gateway classes is required for a particular environment, so that the individual consumers who could be a developers or others that can consume or who can write an application, write the the routing the stuffs and all those things by leveraging those stuffs which are provisioned. So there are different kind of gateways which like self-manage, where the individual if an infrastructure administrator is not there, for example, then the individual developers can also create their own gateway based on these gateway classes which are already, since that gateway is already, by assuming it is already enabled at the GKE cluster level. So they can create their own gateway, and they can create their own routes and leverage. Similarly, in another development team, could be a backend team, they can also create their own gateway and do all those stuffs. In a way, it causes a mess, because it's like, for example, there are some IPs if they're reserved, or if there are some kind of a ports they want to consume, if it is a cross cluster clashing, and if they wanted to, for example, a particular HTTP route in a front end namespace which is managed by a particular team which wants to consume the traffic in another namespace which is back end, then they have to go through service grant. Usually that is what which Kubernetes gateway API. Don't worry about the service grants and all. We'll talk about that. So that definition it has to provide, but if it is handled by the self-manage, and it has through different teams, that would be a complex approach. So that's why the separation of concerns is like, it gives you that flexibility where the admin can provision these gateway classes in advance, and everybody can use it. So he basically can provide an access to different kind of a gateway classes, to the different teams and all those things. So it's a very flexible, it's just like, for example, if you want to route the HTTP, it supports HTTP. If you want to route HTTPS, it supports HTTPS. Basically, similarly, the TCP, UDP, or any other customer is not just based on the URL based. It even supports URL rewrites, traffic splitting also. For example, if you have say around two clusters, one is in East US and another one is in West US, and if you have enabled this gateway API, and let's assume you have enabled a multi-cluster gate API, for example. Don't worry about multi-cluster and all. We will talk about that. So in that case, if you want to split the traffic, 50% of the traffic to one cluster and another to another cluster, you can still achieve with the help of this gateway API. It's so flexible. As I mentioned, these are an open. It's an open source project where the common set of in functionality it's mentioned. Each cloud provider can have their own the gateway controllers. So like I would be taking an example of GKE and explaining about the different sort of the controllers available. So it supports both layer 4 and layer 7. As a, of course, it's that's the beauty, I mean, some of the stuffs supports only the layer 4, but if you wanted to have that complete layer 7 support, I think this is one of the good choice. So that's about at the high level about like what exactly this Kubernetes API is and all. Now let's focus on this, the GKE specific. So if you come to the documentation of the the GKE, and if you come below and click on this HTTP applications, below that gateway API. So if you see this diagram, the same stuff, you have your gateway, which is like in this case the platform provider is GKE, so they can create the different sort of the gateway classes. If you come down, you can see here different sort of gateway classes. So if you see GKE 17 global global external manage, so this is the gateway class which gives a template basically to provide to, I mean, it will basically create an external application load balancer. Similarly, this is for global. Similarly, you have something for regional as well. The regional external manage. This will create a regional. I mean, in a short, or in a nutshell, what we can see that these gateway classes has a direct association with a kind of load balancer you provision. So it's one-to-one mapping. Similarly, you have something for the internal as well, like the regional internal, and then the global, something like that. Then the internal application, you have one. Sorry, this is for the application, the classic application load balancer. So which is again one for internal and one for global, and you have something, these four or five, in fact, you can say this is for your multi-cluster gateways. So we will talk about, what is this single cluster and what is, multi-cluster. You need to have some sort of an understanding about this multi-cluster service prior to, understanding the multi-cluster gateway. And then we'll talk about multi-cluster gateway as well. I would be recording a separate video to give a sufficient introduction about this multi-cluster service and then the multi-cluster gateway. And then in the, subsequent session, we will create a GKE clusters, and then we'll implement the multi-cluster service and multi-cluster gateway as well. Don't worry about that. We would be discussing in detail about that. So at this moment, just, try to understand that this gateway class has an direct association with your load balancers, and it just provides a sort of a template to provision the kind of a load balancer. So if you come below, these are specific to, as I was mentioning, specific to, in fact, these five. So your multi-cluster gateways. So that's about your gateway classes. And as I was mentioning in the gateway, if you see here where you define, how actually your load balancer has to listen to the traffic. So it could be, HTTP based, or it could be, TCP route based, whatever it is. So if you see in this diagram, a platform administrator or a provider will provision these gateway classes. This is done through enabling an API at the GKE cluster level. So that is something, again, in the next the live the demonstration video, I will be showing how to enable this gateway API in a particular GKE cluster, and how we can create we will take a sample Kubernetes, I mean sample microservice, where we'll deploy a sample Nginx application, then we'll create a Kubernetes service, and then we'll create an external gateway definition for that, and then subsequently the definition for HTTP, and how we can consume and interrelate all these things, we will discuss in the upcoming video. So don't worry about that. So yeah, so the administrator, would be providing these gateway classes basically by enabling the API. So and then, again, these could be it's like that once these different gateway classes are enabled, then let's say, for example, he's managing the entire infrastructure centrally, or the different teams can also manage it. So he would be provisioning the gateway as well in a particular place. So again, the gateway can be created in a namespace A as well, even the namespace B as well, or it can be created in a central namespace, for example, an infra namespace, and both these namespace A microservices and namespace B microservices can leverage that gateway. So that is also possible. Or this gateway can sit inside a namespace, and the namespace B can leverage. So here is there is one trick where, let's assume, for example, you have your front end service, for example, which is running in this namespace, and back end service which is running on the namespace. Now immediately, after this gateway, the next component would be HTTP route. So this is the place where you are defining, let's say, one example. I think the concept would be clear. So let me go to one example. All right, let's take an example, and try to understand, about this gateway a little bit more. So I have an example here to do, it's a simple microservice of Nginx, where I'm creating a typical deployment with the three replicas. So, and also, I'm creating, I'm exposing this particular Nginx with a, port 80. So once this application is deployed, now here is the place where I am defining a gateway. So in this example, if you see, I am provisioning a gateway uh, with the help of this gateway class. So if you go to the different sort of gateways here, so this is the one which I am using. So this, which is basically an global external application load balancer. So this will provision a global application load balancer. So I'm creating my gateway of the type gateway classes. So as I was mentioning, moment you enable the gateway API, these different gateway classes are already present in your cluster. So I would be showing in live in the next session. Don't worry about that. So but just to understand, like this is how you define. So this is the definition for your gateway, where you are creating a gateway with the help of this gateway class, which is an externally managed in this case. It is present in a default namespace. Of course, you are free to create your gateway in your own namespace and all. And the name of this gateway is this my gateway. And if you see here, listeners, what I have done is I am allowed the roots from all the namespace. So here is the place where you can restrict it. If you want to allow it for all the namespaces, then a namespace B can also consume this gateway. If it is restricted only to a particular the namespace where it is created, then it has to be changed from all to same. That means wherever it is created by default, it is same, means whichever the namespace this gateway is created, it is consumed only through that. But moment you mention it is all, that means so for example, you are creating a new namespace, for example a test namespace, there you are deploying a microservice, and if you want to define a root there, that root can consume this gateway. That's the simple explanation for that. So in this case, the type of listener would be HTTP. So I'm not exposing the HTTPS traffic. If you want to expose, then you can create your own certificates with a valid certificates with association with a particular DNS provider, and you need to have your own DNS as well, which is a cloud DNS in Google. So that is again it's exposed to port 80 since it is an HTTP. Now if you see here, I'm defining something called as a root. In this case it is a HTTP root. So this is the name of the root. Whatever you want you can create. Again the root I am defining in the same namespace. So here is the place where I am referencing. This is the reference explanation. So if you want to reference a particular gateway with the help of this HTTP root, all you need to do is give the phrase like saying parent reference and then the name of the gateway, and then it has to match what kind of rules it has to match, whether if you have any particular path, say for example slash home slash service, something like that, whatever you want to give based on the kind of where you exposed your service and all with the name. Now in my case it is not, so there's just a default I've given a slash, and the service which I'm consuming here is Nginx with the help of port 80. So this is the service, whatever I created, that I am consuming, and whatever the port I have exposed. That's all. That's all. Simple. So if you deploy this gateway and route, then the gateway will be, changed to true state, and it will give you the public IP. Once you hit the public IP, you will be able to see it, which I'll show in the next session. So let's come back to our documentation and the explanation. So whatever I hope now it is making sense, because I've shown the like how the gateway definition looks like and how the HTTP routes can be defined. So here is one trick. So let's assume the HTTP route. Let's assume this namespace A is a front end, the namespace B it contains the backend application. Now, if a front-end HTTP route, whatever is written in the namespace, say if it wants to consume the backend service, whatever it is written in the namespace B, then this would be a cross namespace consumption. In that case, what you have to do is in the namespace B, you have to write something called as a reference grant definitions. For example, here the front end service HTTP, whatever the front end HTTP route, whatever it is defined, if it wants to consume the service which is part of your HTTP route in the backend. So first what you have to do is in the namespace B you have to write a service grant definition which references what kind of service the service grant wants to use from class and to class, that will define, and then it would be open. So a sample example for that, if you come down you can see here, for example the front, if you see here the from field and the source namespace, the HTTP route in the front end namespace. So this is the reference grant which I'm writing in the back end namespace. So allow front end to back end is just a name, whatever it's just for simpler explanation purpose. Google has given this. So now here's the place where you define from section, from the gateway, whatever the HTTP route, the part of the whichever the gateway, that gateway group name basically. It's need not you need not to mention the actual gateway name. It's just a group of the gateway itself that you are mentioning here. So the HTTP, what kind of thing it is? The HTTP route, which is present in the namespace, which you are consuming inside a here. Because moment what it is trying to consume, it is trying to consume a service. Which namespace? Backend that I have already written. So this is how the cross namespace consumption can also be done. That's another beauty of this. So that's about the reference, grant. So this is how that a typical stuff, looks like. And another important stuff here is the policy. So when you say when you talk about policy, let's assume already ingress in sort of an ingress you define different sort of front end policies, front end configs and back end configs and all, right? So this is almost similar to that. See, for example, if you have a GCP gateway policy, like which refers to your front end config in the ingress place. Similarly, your GCP backend policies refers to your backend configs. Also, you can have the health check policies, which is basically at your like whether the particular backend parts, whatever it is associated with the load balancer, whether they are active or not. If it is not active, then how the load has to be distributed, and all those things you can define at the policy level. So that's about that. Now let's talk about the different gateway usages. For example, how you can consume the gateway. Let's talk about this self-managed gateway. As I was explaining in the beginning of the session, let's assume there are no single owners and your platform you know admin is not bothered to maintain it. Then what happens is like the individual the teams, for example the development team A and development team B, which is managed by again the owner of that particular team, they can come and provision their own gateways. I just showed the example of the gateway, so they can create their own gateway in the particular namespace and they can provision their own IPs and all those things. Similarly, the another uh, person from the developer B, he or she can also provision another gateway and they can consume and all. At that time, if any of the DNS names or any of the host names, any of the IPs, if one person is already used the same thing which is provisioned and unfortunately they wanted to use the same thing at the other place and all, the kind of an clash it provides, it's a messy and if any user or any of the service which is present in a different namespace which is managed by a completely different team has to consume, which is basically a cross namespace reference with the help of a reference grant, it's a very hard to coordinate because it's totally with a different team and you have to get hold of the individuals and you have to start looking about the way it is configured, the IPs, IP clashes, the DNS clashes, all those things, it's a messy. So it's never recommended to have their own self-managed gateways. Rather, you provide the platforms to have that gateway so that they know what sort of gateways they are allowed for a particular team to use and whether they can consume from all the namespaces or whether they can consume only from a particular namespace. I just shown one example here whether they can give reference for all the namespaces for a particular name. So all these kind of controls, if it is provisioned by a platform managed gateway, that can be done. So in this example, if you see a platform admin team is provisioning two different gateways. Okay, so one is separate for the store and one for separate site microservices. So it's totally isolated. It's and they know what kind of gateway they provision for two different microservices, which is again in one particular namespace, which is completely managed by your platform admin, and there they are showing the reference that this gateway from which namespace it can be referenced. For example, the store, it is given a reference only for this particular. Similarly, for this site, given reference only for this. That's the beauty, if you have that admin manage this. So this is one of the simple. Similarly, you have something called as a shared gateway per cluster. So let's assume for the entire cluster, there are three different teams. So in this case, there is a mobile team, there's a web team, there is an account team. So what platform admin team, and the scenario is like your mobile team and a web team wants to consume, the services inter-exchange. Like some team, they wanted to have that coordination cross namespace reference, and also, they wanted to get exposed through a common DNS name. For example, in this case, either it could be a mobile.example.com or m.example.com/mobile or /web, something like that, or using subdomains they can reference separately like mobile.example.com or web.example.com. It's totally, the way we write that definition, or the kind of the domain which we have registered. It could be a I mean the certificate, it could be a wildcard, or it could be an individual alias records which is defined at the subdomain. I mean, it's basically at the implementation, reference specific. So let's assume the in this case, what the infra admin, our platform admin has done is he has created a namespace called infra, and he has created two different gateway. So here in this case, the external gateway, it could be an external, globally external or regional external, it depends on the use case. So he has given a reference that both your store and site can use the common. So in that way he has given a flexibility, he has allowed two different namespaces there. Similarly, whereas the internal gateway, which it serves only the sort of an internal traffic, which where he has created in that way, the internal load balancer, so that serves only the traffic within the VPC. So still he knows what kind of traffic he is exposing to three different, and the isolation and everything he is controlling. That's the another example. So similarly, in case of a multi-cluster gateway, what you are doing is you are creating a gateway in one cluster, and then that you are exposing it as an ingress sort of stuff at the fleet level, and that can be consumed for multiple. So for that you have different kind of in gateway controllers. So as I was mentioning, each cloud comes with their own gateway controllers. GKE has two, single cluster and multi-cluster controller. So let's see the comparison. The single cluster controllers, we have already seen the examples. So there are around 4 to 5. This is specific to Anthos service mesh, whereas this can be consumed for all. So if you see similarly, it's just that hyphen MC reference to multi-cluster. So now let's see the compare one by one. So if you see the single cluster gateway, it just supports for single cluster, whereas multi-cluster it supports for multi-clusters. So this is deployment location. It is regional, in the same region as in the GKE, whereas this is global. Basically you can like if you are deployed your microservices across different regions, and this can be exposed. The beauty about the multi-cluster gateway is, it's not just sends the traffic at the load balancer level to your microservices. It has a very intelligent mechanism to send it to a closest location as well if your application is spread across the different, because ultimately it has that mechanism to send it to different locations which is nearer to that, some kind of an edge kind of a stuff. And also the traffic splitting, if you want to split the traffics equally, or maybe a 70/30 or 50/50, some kind of a stuff, that can also be done with the help of that. So how we enable the single cluster gateway? Just by enabling the gateway API, whereas the multi-cluster, of course, you have to enable the gateway API. On top of that, you have to enable something called as an ingress API. This is what I was mentioning. So that's very simple explanation for that. So in the next session, we would be focusing on a separate video dedicatedly, where I am showing you that how we can create enable the gateway API, how we can define this gateway definition and the HTTP routes, and how we can expose it with certificates and without certificates, both. How we can leverage that. I would be recording a small video on Google managed certificate as well, because I don't know how much familiarity individual users have about Google managed certificates, because there is a trick. There is a classic certificate as well, and then the actual Google managed certificates, or even the self managed certificates as well, can be created through Google Certificate Manager, and then how it can be associated with a particular DNS and all I am showing in a short video, because I thought that is necessary for the individual users to know end to end before jumping into the actual implementation with certificates. So with that explanation, we'll meet in the next session. Thanks for supporting me, and please do support me as well for further as well. So please do subscribe to my channel and stay tuned. Thank you.